I'm sorry. We've got a couple of comments for Carla. This is City Roseville and 4-leaf, is the outside plan over here. And a new comment or something that they
a
did
new
not
comment.
resolve?
Yeah, first of all, pay your fees. We all know we have to pay. The owner has to pay his fees.
Right.
We rejected the special inspections company, you know, because we asked Hernani and Mike brothers,
Who do we use?
what do you guys want to use? Oh, we use this guy all the time. He's
Right,
like from Merced, Modesto, because that's where most of their car washes are.
right, but he's not on the list for those.
So-
Dan,
Yeah, hey, Joel.
Dan, we can hear you, so you might want to put us on mute.
That's okay. We're talking about you.
We're talking about you. That's okay.
Not me, I mean business, if you don't want it known.
I
Just saying.
know, okay, good point.
Thank you.
I'm muting.
Hi, Scott. Santa
Hey,
Claus,
Joel,
Santa Claus.
what's going on?
Hey, not much. My Revit doesn't work on my home machine, so I'm dialing into work to run Revit.
Oh, geez.
Yeah, we'll see how it works. I need to, let's see.
Let me let's see. Oh, where's all my stuff on my laptop? Oh, geez. I'm not in the mood for this today. Yeah, none of my shortcuts are showing up on my laptop.
Great. Two, huh? Computer woes.
Everything's, yeah. Do a restart. Maybe that'll fix it. What the heck is that? ¿Dónde está el César? Es no aquí. Host is not in the meeting yet. Oh, look at that. Okay, I'm ready.
Hi, everyone.
Hey, there's Cesar.
Sorry, I'm a few minutes late.
How are you?
Hey, Scott. I love that new outfit. Looks like you have a very nice man cave on your office, Scott.
Oh, yeah. And you get old enough, you finally get to have one.
All right, welcome everyone. I'm sorry I'm a bit late wrapping a few things here, but I'm back into the States, and that means I have high-speed internet again. Let's see who is here. Hey, Joel, welcome.
Yes.
Let's have Andrea also, and Casey, Dan, Jacek, Lisette, Michelle, and Scott. Let's give a couple of minutes for people. And Savita, hello, welcome. Go ahead and go over the attendance sheet and find your name here. What's this? Okay. All right, so welcome to our class, February 15. Now that I'm back in the States, I'm going to be able to stream this into the YouTube channel, which I wasn't able to do for the past couple of weeks. My apologies about the recordings. They're still on the cloud on Zoom, and I haven't had a chance to download them. My first day after I flew back yesterday, and today was so busy at work. So I'm going to find some time in the week to download the recordings from the past couple of weeks and re-upload them in the YouTube channel. But today I'll stream the class as it should be. Let's see. We'll start sharing the screen here. All right, so today is the 15th. We did not have a class last Thursday, and we discussed the process of creating walls and create a custom wall. And we are using the Mila footprint as a way to understand these concepts. Today, we're going to catch up. We're going to talk about loading, managing component families. We covered this already. So I'm going to catch up today with grids and columns and floors. And maybe start a discussion about materials. So I don't think we're going to be behind schedule anymore. The data sets for today, it's where we left off last Tuesday. If you were not in the class, I made a copy of the data set in the Google Drive. I'm going to copy the link here. If you don't have you can continue with the data sets that you left off on last Tuesday, or you can download this data set, which is the file that I'll be using on the screen. It's Mila Heat start 3.rbt. The link is on the chat panel. Just hit on it and download it. If you want to start with my data set, if not, you can feel free to continue using your own data set. Okay, make sure you sign your name. I don't expect to miss any class moving forward, so we should be okay. All right, any question about the schedule for today in the next couple of weeks? This week and next week, so the next 3 weeks, we're just gonna focus on this data set the next couple of weeks. And we're gonna try to wrap this up by next Thursday. And then starting on March, we will jump into the documentation and data analytics. There we're going to jump into how we manage information inside Revit, how we add custom information, the different type of parameters and scheduling data, moving information in and out, and then additional documentation, workflows, detailing, phasing, managing sheets, etc. All right, so this is the data sets. Hopefully everybody got that. I am on level 1 and I'm going to start streaming this on YouTube. Give me a second. It says grant necessary privilege. I don't know what's going on here. That's me. I'm not sure what's happening. Trying to go live, and in the past this has worked, so I'll have to probably have to review this after class, but I'm gonna record anyway on the cloud, which isn't doing it right now. I'm recording on one. I don't know why the live on YouTube is not working. I'm gonna try it one more time. Yeah, grant, but I don't know. I'll sort that out. What means that the recording will be on the cloud, but I'll have to download and re-upload. Okay, I'll sort that out. But all right, so we are on the Mila house. And last time, where we left it in the last week was we created wall-based or wall derived from amassing objects. And we created a representation of the house as you see on the screen. And I helped some of you sort out some difficulties at the end of a class. One of the things I want to review quickly is how partitions connect in corner conditions, because I think I went very fast on that. And for that, you don't have to do this. I'm just going to create 2 different type of walls and start a discussion on how that works. So I'll have 2 walls connected in the corner, and then I'm going to switch one type with another one. So we have 2 dissimilar walls connected in a corner. I'm going to switch this to fine, and you can see how I have all these different layering systems. And so one of the things I explained last time is that in corner condition, there's always a primary wall and then a secondary wall. And the primary wall is the one that dominates the corner condition. In this case, is this partition. And then the internal layers of 2 different walls connect using the function and the priority number. And if you recall, the priority number is a Revit way of connecting different layers that have the similar functions. The easiest to understand is the structural layers, that if they share the same materials, they connect seamlessly. That's why, in this corner condition, we have the core of this wall connecting seamlessly with the core of the other wall. They have the same width, they have the same material, so there's a clean connection. Now, take a look at this other one. This is a finish in one of the walls. And then this is another finish. And they have the similar materials. And that's why you see that because they have the similar materials, they represent differently. And therefore, you will see that they abut, but they don't merge. And so the other thing we did in the last class, it's understand how corner conditions can be modified. And we use this tool under the Modify tab called the wall joints. And wall joints allow us to override the default behavior or the default relationship between the primary wall and the secondary wall. And so I'm going to illustrate it now how this works. So if I go into the Modify tab and then you hit the wall joints and hover over a corner conditions, you're going to see this big square around the corner. It's just a way to identify visually a corner condition. And as soon as I select it, I can cycle between different corner conditions as using the options in the options bar. So I have three options: butt connections, meter connections, and square of connections. So if I hit the next button, the next button here, I flip the primary wall in a corner condition. And sometimes you may want to do that, sometimes not.
Let's see.
And then as you hit next, you keep cycling between potential options. But in this case, I only have two options. So every time I hit next, I only have two choices to work for. Now, the other option is mirror conditions. And mirror conditions, it's a corner conditions where you have mirror condition. This is sometimes not the way things get built on site. But if you're doing furniture construction or you're doing some kind of wood construction, sometimes that's the way to create those corners. And if you just care about the visual display of a symbol, sometimes meter works or create the desired outcome.
Hey, Cesar,
Yeah.
remind me right now when I look at my walls, it's gray and black. How do I get it to where it shows all the different patterns?
Yeah, just go into the detail levels and the view controls and switch those to fine.
Ah, thank you.
Yeah, when you switch to coarse, they are grayscale. When you switch to fine, all the layers are displayed. Okay, so I was talking about corner conditions. We have the meter conditions. And then there's another one called squared off. And this is a condition in which layers of the same function will be forced to align perpendicularly. Notice how the butt condition and the square of conditions are similar, but they differ when I have different angles. Right now, both the connection angle between these two partitions is it's 90 degrees, but as soon as I turn that to be another angle, you can see now that this corner condition has a square of connection. When I do it again, this is the corner condition. but condition that is forcing the layers with the same function to connect, and square off makes the primary wall maintain perpendicular layers and make a connection with the opposite wall. It's just different ways of dealing with that connection. And then when I click the next, these are the different options that I have. So again, what conditions? These are the two different options. When I click the next, those are the different bot conditions. That sounds weird. Then we have meter. Then we have a squared off. And every time you hit next, you get a different condition. Now this is a Revit educated guess to display how connections work. It may or may not be how you actually build it on site, but I think as a educated guess, it's a good way to display it at a certain resolution. When it comes to craft this at a greater detail, if this was a detail of a corner conditions, I would review this with a technical eye and maybe make changes and amendments on how the different layers connect and the different connection types. So I just want to mention that because I didn't explain it very well in the last class. Does that make sense? Modify wall joints, and then you can navigate through different wall connection options. All right, I'm going to delete this and let's go back to our project. What we're going to do today is to continue looking at the interior walls, and there is a footprint in the background of how what's the display of different walls. So we're going to build new wall types based on existing ones. And so for the core, there are a couple of cores here, like restroom cores. And let's focus on this one. It's where the kitchen and the little restroom is at. So this wall, I have to assume it's a simple partition according to the pictures on the Google Drive. It looks like it's all plywood finish and a wood core. And that's what we're going to do. We're going to create a new partition, and we're going to allocate material and textures and create one from scratch. So let's start with a generic 6-inch wall. And so you go to the architectural tab, build a wall, and then we need to decide if we treat what's going to be our location line. Remember, location line, we have the center line, core exterior, core interior, face interior, face exterior. And the core is the work plane along the wall that anchors it to the ground. And so if I want to trace this and I want to be precise about it, probably the best way to do this is place the wall using finishes, the exterior finish. And so before I continue, I want to show you something about the direction of wall creation, which impact the direction of a wall. I pick here the exterior face as the location line. And so when I create a partition and I use this method, notice how if I create the wall using a clockwise direction, the exterior wall is going to be towards the outside of the wall. So how do I know what's the exterior side? Remember, you select a wall and that double arrow indicates the exterior side of a wall. So again, when I create a wall and I select the exterior face as the location line, here I'm going to select the generic 6 inches. If I create the wall using the clockwise direction, then the exterior side is going to be facing outwards. Now, notice what happens when I do the opposite direction. Wall, generic 6 inches, and instead of creating it clockwise, I'm going to do it counterclockwise. So I go this direction, and so when I do that, then my walls, the exterior face of a wall is pointing inwards. And that's why, yes, in the last class, a couple of you created the walls in a different direction, and the walls appear a little offset from the representation in the background. I don't recall who did that, but when we create walls, we need to be cognitive about the direction in which we create the walls, because that's going to determine where the exterior wall or where the face of the exterior wall resides. Does that make sense? All right, so I'm going to delete these two things here. Another thing I'm going to do is make sure that I pin this image. I think it's already pinned, but if you don't want to move it by mistake, select the image and use the pin tool. The pin tool is under the modifiers of the raster image in the contextual tab. And then you're not going to move it by mistake, which happened to a couple of you in the last class. All right, so let's start with we're going to trace this restroom. We're going to use a 6-inch stud wall. And we're going to use the exterior face, and we're going to use the exterior boundary as our tracing outline. So on the architectural tab, select walls, pick the 6-inch generic wall, and I'm going to do clockwise. So I'm going to start with this corner, and then I'm going to go to that corner. And I'm just tracing the outermost line in the sketch space. Then I'm also going to do the demise wall. So I'm going to create the demise wall here. Those are the walls I created. You may want to switch your display to display wireframe in level 1. And the reason to do this is so that you can, the image is readable and is not blocked by the object themselves. So, you know, when I switch this to wireframe, I can still read the image, and the objects on top of the image are not getting blocked. All right, so this is the 6-inch partition. These appear to be 4 inches. So if that bothers you, we create 2 different partitions that are similar. So, with me, this was easy. We created 5 different walls using the exterior face as a location line. And let's define the properties of this wall, the one adjacent to the kitchen. So right now, this is a generic wall. It doesn't have properties associated with that. So we're gonna edit the type of this wall. So on the screen, select the wall and edit the type, which is gonna open the type properties. And remember the three, I'm gonna create a new type based on an existing one. Again, this is something we talked about last week. So to create a new type, we duplicate, then we rename, and finally we change parameter values. And we're always going to do this every time we create a new symbol based on an existing one. All right, so using these three rules, I'm going to duplicate this type because I don't want to override the existing one. I'm going to give it a new name. Sometimes the name aligns with the can be very descriptive. Some companies decide to name their interior partitions based on their internal standards. Maybe they have a code associated with that. I'm going to be descriptive here, so I'm going to say this is a plywood, 2 layers of plywood, plus a 4-inch stud. 2-ply plus 4-inch stud. And that way, you know, when a user is trying to select the right partition, then they could just pick it. They can just, you can discover the construction just by looking at the name. Naming partition, again, it's all based on company standard. So I call this 2 plywood plus 4-inch stud. Then I'm going to go into the structure. So edit the type. This is just 1 layer at the moment, and it's 6 inches in thickness. So I'm going to change the structural core to a 4-inch core. Hit on the material, and then those 3 little dots, we're going to assign, click on those 3 little dots, and then we're going to assign a material. The material I'm going to assign, it's a wood stud. So if you, this is the material browser, which discloses all the materials that have been brought into the project via the template. And there is a limited set of materials here. Not all, this doesn't represent all the materials that you can build in Revit. It's just a subset of materials that was part of the template that was used to create this project. So I'm going to look for the word stud in, or let's say wood. And there is a softwood lumber here that I'm going to use. And then hit OK. So my core is made of softwood lumber, 4 inches in thickness. And then on the interior side and the exterior side, I'm going to have 1-inch plywood. So I have to add a couple of layers. To add a layer, you select a row. I'm going to select row number 1 and insert. And then I'm going to add another one that's for the exterior and the interior. these layers, I need to properly place in the right order. So I'm going to select row number 1 and use the down button to move the layer in the appropriate location. You can use the preview button to display how it looks like. So again, when inserted 2 layers, select one of the layers and move it down. The thickness for this layer is 1 inch. And I know that 1 inch plywood is not that typical, but if you want to do it 3/4 of an inch, you can do that too. And then the core is going to be 4 inch. The layers for the exterior, it's going to be plywood. So hit the material and look for the plywood sheeting. And the same for the interior side. Instead, you can copy paste materials from one cell to another. So instead of searching the material, you can Control C and Control V. Then I'm going to change the function because they both share the same finish. I'm going to use finish 1 for both of them. Again, the structure I say was going to be a softwood. So I have a new wall made of 3 layers: softwood, lumber, plywood sheeting on the interior and exterior, 1 inch in thickness. And then if you want to see on the preview, this is how it looks like. It looks yellow because yellow is the shading color inside the material definition. Let me show you that. If you see this color definition RGB, that is sort of yellowish. And so that's why this looks that color. And then I hit OK. And another thing I want to do is I want to display these walls as solid black when I switch to coarse view. So in the type properties under the core scale fill pattern, I will assign a fill pattern of solid fill. And notice how it says coarse. And what that means is that when the view resolution is set to coarse, these walls are going to switch to black color. So I hit apply here, hit OK. And I got my 6 inch wall in this location. Any question here? Was it easy? Do you want me to repeat? All good here? All right. So I'm going to repeat the procedure, and well, all these are generic walls, right? Let me show you a very nice shortcut that we use quite often in Revit. And that's match property. The match property copy the type properties of one object and apply it to another one. Or in other ways, it's swap the type from one to another type. And the match properties, which is similar to the AutoCAD mod, it's living under the modify tab. And then you're going to see under the clipboard something called match properties. It's the shortcut, it's MA. So I like to use the shortcut just because it's easy. So if I select a wall and then I say MA, it's asking me to copy the properties of a wall and apply it to another one. All right, I'm going to do it again. I'm escaping here. So to use the match property, just type on the fly MA. And now you're going to see that the cursor turns into this little like brush, and it has a white brush. And what that means is it's like you're about to paint something. And so you're going to place that brush into the paint bucket, and then you're going to pick the properties of that object. When you select the property of that object, the cursor turns with black. It means that it's already wet. And then you're going to apply that same properties to the rest of the objects. And then you can continue applying it until it's finished. So again, MA is the shortcut for match property. And this is frequently used in modeling. It's easier to apply match properties that select a wall, look at the type selector, and then browse all the different types and swap them. Okay. Now, if we want to follow we want to go by the sketch in the background, it looks like these partitions may not be 6 inches, but they probably be 4 inches. So what I can do is, again, create a new wall type based on an existing one, and then I just change the core properties. But I'm not going to do that. I'm just trying to save us time here. If you feel compelled, you can do it on your own. Okay, any question here? Now let's look at this. This is a representation of the insulation. And Revit walls, unfortunately, cannot have embedded type definitions of these insulation, but we can place those representation on top of it. So these are view specific objects. You'll find it under the Annotate tab. And under the Annotate tab, you're going to see something called insulation. And this will create a bad insulation of a certain type. So this is going to be inside the cavity. So I'm going to make this 4 inch. And then you click a point at the center of the wall, and then a point at the opposite end, and hit escape. And that creates graphical representation of batt insulation. We often never use or represent this in floor plans, maybe in details, but this is, if we want to like recreate what's on the background, that's the way to do that. Again, you go, I'm going to escape, repeat the instruction, you go to the Annotate tab, and you go into insulation under the detail panel and change the width to 4 inch and draw it at the center of the wall. And I'm just doing this to follow along the representation in the sketch in the background. Uh, these bat insulations have the density between the bulges can be changed. That's something in the instance property. So if you want this to be like denser, you can change the ratio from 2 to like 1.5. That makes it bigger, or you can change it to 4, and the bat looks tighter. It's this instance property of the bat insulation. The bigger the number, the tighter the representation of the bat insulation. So I'm changing this to 4 just so that you see the effect. Doesn't matter. Okay. Easy. Let's look at this in 3D. So this is what happening in 3D. Our walls, when we create a wall in Revit, the default height it's 20 feet. And so this wall has been created from level 1, and then it's 20 feet up in the Z direction. And but we can force the walls to extend to the underside of the roof using the attach button. And so let me show you how that works. So I switched to a 3D view. You just click the 3D house in the upper left side. And to extend this wall to the underside, well, let me just check that that's the way it is in the pictures. So give me a second. I'm gonna open the Mila and look at some of these pictures here. I'm not positive. It might not. No, you see, no, they extend. They don't go all the way to the underside of the roof. They might go, I would say, 7.5 feet or 8 feet. Let's do 8 feet. It looks like here on the top, I don't know what those kids are doing upstairs, but it doesn't look like that's a playground. So it's not going to go to the underside of the roof, and so what we're going to do is select these walls and change its unconnected height to 8 feet. And we're going to do it for all of them. You can just control select and change the unconnected height to 8 feet. And that should take it under the roof. All right. Any question about partitions? Okay. We could also build the partitions in the bedroom, and it's going to be exactly the same process. I'll keep using the 6-inch wall. If you want to create a 4-inch wall, go ahead and do it. Just for the sake of time, I'll stick with the 6-inch wall. So I'm going to go Control C. Here's another shortcut that I want to, that it's a frequently used. And this is super useful. This is called CS. And CS means create similar. And what this does, it's you select an object, type CS, and it will create the same object you have selected in a different location. So another frequently used shortcut. So if I want to create another wall here, you just select the wall. Make sure you don't pick the insulation. The insulation mat, it's not a wall, that is a graphic. So what you do is select the wall and then type on the fly CS, create similar, and it's going to create exactly the same type of the object selected using the finish face exterior. And then again, I'm going to trace over the these walls in the clockwise direction so that the exterior side is on the it's pointing outwards. I'm going to create another one for the demise wall. You can move objects using the arrow keys. Let's see, I'm going to very quickly create a new type, the 4-inch partition, you know, the process. So again, I'm going to edit the type, duplicate, and instead of being 4-inch stud, it's going to be, I don't know, 2-inch stud. And then edit the type and just change the structural core to 2 inches. And then match property. The shortcut for match property is MA. Pick the source and hit the destination. And I may do that here as well, because that seems to be a smaller partition. Okay. Notice how here I have a combination, like there's a thick partition, and then there is a 4-inch partition associated next to it. Like this wall needs to be split in two. So I'm going to show you the modifier called split. This little square indicate where the split command is. And split divides wall at a selected. When you hit that icon, the cursor is going to turn into this X-Acto knife. And then you pick a point in the wall and it's going to divide it in two. And then you can swap the type from one to another and have this dissimilar width wall, dissimilar wall. So again, split, the cursor turns into this X-Acto knife. Select a point in the wall. I think Revit likes to select points that align with wall faces. Escape. And then this little piece of wall, I'm going to swap it from one type to another. I'm going to use match properties. So MA. Modify match property, pick the source, pick the destination. I also have to create this one. So architecture wall, or I select this one and say create similar, CS on the fly. Again, select this one, CS. And I have that. And now I have my second core, sort of similar to what the background looks like. I'm going to look at the interior of that. Let me see if I can find it. Yes, in that core, I think that this is a section through that bedroom, and those indeed goes all the way to the underside. The second core, the first core, which is in front of the kitchen, they go 8 feet above ground. This one is going to go to the underside. And once you finish creating these walls, let's switch to a 3D. You can switch this to wireframe in 3D to display the interior walls. And this is going to allow you to pick walls and extend to the underside of others. So these are the walls I'm trying to select. You can switch to wireframe, but I don't recommend working on wireframe because this is going to start to get really, really busy. And so one thing you can do is to enable the section box of a 3D view and create 3D cuts. Again, if you want to do this with me, switch to a 3D view. And then in the property windows, select the checkbox called section box. This guy here. Section box, again, it will enable a crop boundary around the 3D model. And you can use this 3D boundary to create 3D sections. So I'm going to pick a section here. I'm going to pick one of the crop boundary faces. Now you can see how I can start trimming the building in 3D. And the reason I'm doing this is because I want to be able to pick the walls and extend it to the underside of the existing roof. So now that I have my 3D, my section box, again, you go to the property windows and enable the section box. Select the section box in the 3D space, grab the double arrow control in the north side of the building, and just stretch it enough so that it discloses the core that I want to change. And this is how you extend a wall to the underside. All right, any question here? Anybody want me to repeat anything? All good? All right. The interior walls of,
Cesar,
yes.
how do you shrink the walls in the first place?
How do I shrink this wall?
Yeah, because they were 20 feet and you made them smaller. Where did you do that?
Good question. So you select the wall and then in the instance properties,
Yeah,
check the unconnected height.
okay. I don't know if I have that.
Select the wall and then unconnected height.
I don't see unconnected height anywhere. All I have is constraints. It's just not an option in the menu. Maybe I'm in the wrong place. I don't know.
It should be, if you select the wall, it should be right here.
Constraints. I don't, okay, it's not, I'm sorry. Now I see it. Thank you.
Yeah, it's an instance property of the wall.
Okay, thank you.
Anybody else have a question? Yeah, so to expand on that, the height of the walls can be specified as unconnected height, or it could be associated to a level. In this particular project, I only have one level. I don't have multiple levels. So I can force the wall to go from one level to another level if I choose the top constraint. But in this case, it's unconnected with a specific height of 8 foot. 8 foot. Okay, walls. What we're going to do now is to force the wall to extend to the underside of a roof. And to do that, we're going to use these commands. It's called attach top base. And the reason it says attach top base is because you can extend the top of a wall to another surface, or you can extend the base of a wall to another surface. It depends on what you choose. So to enable that command, select the partition, and I'm probably going to start with the one in the back so that's visually better to work. So I'm going to select the wall in the back, and then this is the contextual tab, the modify walls, and you hit attach top base, and then you pick the wall you want to extend it to. Let's see if to attach this to this. Oh, you know what? It's not going to work because this is not a wall. This is not a roof. It's a wall. Attach this to this. Damn, it's not working because I build this as walls. So for your records, you can only extend walls to roof, but I cannot extend it to another wall. Let's see if I can use roof instead. I select this wall and I swap it to generic roof. I'll have to recreate it. Oh crap. Let me try something here. I'm gonna switch off the I'm gonna hide in view the category of, and let's see if it works there. Attach top. Yeah, it's not working.
Could you change it in the instance properties table?
Can I do what? Sorry.
Can you change it in the properties table? Can you change in the table the top constraint? Can you select something else instead of unconnected?
I can assign it to levels, but
Okay, the roof is not a level. Okay.
there is, yeah, there is no level, but there's something I can do. But I need to switch to elevations to do that. So I'm going to go to the north elevation. And what I can do is to extend, I think I can extend walls to reference plane. And so what I'm going to do, let me try it first, and then we'll do it together. So I'm going to go to the architectural tab and create a reference plane and use this sloping surface as a, I'm going to create a reference plane here. And maybe I'm going to move it a little below so that the wall doesn't, no, let's try that. I'm going to select this and give it a name. This is going to be sloping roof. And I'm in the north side. Then I go to 3D view, select this and attach. Oh, no, I stay on the north side. I switch this to wireframe. Then I select this wall. I just hit tab until I select it and attach stop base to that. Yeah, there you go. So let's do it together. So what I did is go to the north elevation, and then I created a reference plane. I'm going to give it an offset of -4 inches so that the reference plane is a little below the top of the roof. And then I'm going to snap it to the this inclined surface. So this is a sloped reference plane. I use tab to cycle and be able to select it. This is our reference plane, and walls can extend to reference plane. And so, again, architecture reference plane, I use the line tool, and then I give it an offset of -4 inches. And then 4 inches from where I pick, it's going to create that reference plane. I switch this to wireframe so I can see the walls behind. Just hover over and you just hit tab in order to cycle on all the objects below. I select one of the walls, attach stop base, select the reference plane, and it will go to that reference plane. And I need to repeat the process for each of the walls. Again, tab, attach stop base. You can also do window selection. Grab all those walls in the core, attach stop base, select this, and then they all go to that work plane. That makes sense. So repeating, I can do enclosing window selection, which is a window selection from lower left side to upper right side. Make sure you do not select any of the exterior walls. You just want to select the walls on the core. And then hit attach stop base and select the reference plane. And all those walls are going to go to the to that reference plane. Then in 3D, they look like that. Now, the reason I choose to use a wall instead of a roof, it's to allow for a clean connection at the corners. So if you notice, look at this section and notice how the walls and the roof, they have a very, very clean connection. If this was a roof, then it will be stopping. There will be a very they will stop. You will see a hard stop, and that line will read all across the exterior walls. And I was trying to avoid that. And sometimes you have to use these things in Revit to make things display properly the way you want. Okay. If you finish this with me, feel free to do the same thing at the oval core. I think this also extend to the underside of the wall. But I'm looking at the time, and yeah, let's do it quickly. So these all seems to be like 4 inches. So I'm going to make it all with 4-inch walls, create similar. Select a wall, create similar. See your face. So I'm going to do trace over here, here, here. Escape, and then another wall here. To the left. And then again, I'm going to have to extend this to the underside of a reference plane. So I need to draft that reference plane on the south side. So I'm going to switch to the south elevation and create a reference plane 4-inch below the roof line. So architecture, reference plane, give it an offset of -4-inch. In the offset cell, I'm in the south elevation. And create the reference plane. I'm going to tab select it and extend it so that it's easier to select later. Then switch to wireframe. Oops. Switch to wireframe. And select those 4 little walls, 5 walls. And attach top base to that reference plane. And now I got that. I'm going to pull this in 3D just to display this. There you go. This is one room with the extended walls, and this is the other one. All right, I'm going to let you work on these walls, let's say for the next 5 minutes. Let's try to wrap this. And then if you are done, you can have a 5-minute break. I'm going to have a quick bathroom break, but at 6:50 or so, I'm going to come back and show you, talk more about, we're going to try to tackle the windows, and then we'll finish again. All right, I'll be right back, guys. If anybody has a question, let me know. All right, it's almost 6:50. Anybody has a question? Anybody need help on the walls? Simply was pretty straightforward. I guess the tricky part here is to make sure that we have the appropriate reference planes and that we're able to select walls and extend it to the underside to the underside of that work plane. Okay, I want to create for the next 20 minutes. I want to have a discussion on how to create a floor. And a floor, it's a system family that utilize sketch lines to define a boundary. And this is the first time we're going to create a sketch-based object. And so floors, if you recall my slide deck, we have system families and loadable components. And loadable components are things you load from an exterior library into Revit. Windows, doors, and furniture are examples of loadable components. And then we have system families, which are the hosts of those components. The walls, the floors, the roof, and the ceilings, those are examples of hosts. Now, when we create a floor, we have to define what is the boundary of that floor. And Revit switched to a temporary display called sketch mode. And sketch mode, it's the contextual tab that only allow me to create sketch lines. And sketch lines are these purple lines that must be connected into a closed loop in order to create representation of an assemble. So let me show you how to create a floor. I'll do it first, and then we can do it together. So under the architectural tab, I'm going to hit the floor command, and this take me to sketch mode. So this is a contextual tab. And then you're going to see also that there sketch mode, it's the place where you build sketch lines. And the only thing you can do in sketch mode is to create sketch lines. And so Revit is asking you to create the boundaries of that floor. And when you're done creating the boundaries, you must click the green checkbox to exit sketch mode. Now, there are two rules of sketch mode that everybody must understand. And I'm going to write them here because they're in the exam. Rules of sketch mode. The first one is that all sketch lines must be in a closed loop. And the second one is that all sketch line must not overlap. If you don't follow these rules, Revit's going to get angry at you. It's going to display this message that cannot create an assemble. And so sketch lines must be a loop of connected lines. If there's a gap in between those lines, you won't be able to create the floor. And then the lines must not overlap. You cannot have two sketch lines on top of each other. You cannot have the sketch lines overlapping. So let me give you an example here. When I create a loop, if I create a loop of boundaries, and then notice how there is a gap here, and then I click the green checkbox, Revit gets angry and says, you can't do this because the loop is open. So you must continue and close it. All right, I do that. And then the second rule, boundary lines or sketch lines cannot overlap. Here I have two overlapping sketch lines, one on top of another one. And when I hit the green checkbox, Revit is angry again. You cannot have overlapping lines. So as long as you have a closed loop of sketch lines and they connect neatly corner to corner and they don't overlap, you will be able to create this floor. All right, let's do it together. So I go into the architectural tab, floor, and I'm in sketch mode. How do I know? Because I am in the contextual tab. I see the draw tools, and the only way to get out is by clicking the green checkbox. Now I'm gonna build lines, so I use the line tool here, and then I pick floor type. I'm gonna use a generic 12-inch. Maybe this is concrete. I'm sure this is concrete. So, but I don't have a concrete floor here, but we can work on that later. So I'm going to create a generic 12 inches. And then we're going to just trace over the intersection of the lines. So just remember, our walls are aligned with the core exterior, and we use those reference plane as guidelines. So all I'm going to do is trace over those intersecting reference planes. I'm just going to go all around the walls. If you happen to make a mistake, like I'm doing right now, oh, this is a mistake, then just hit escape and delete what you did and continue placing boundary lines. So I'm just snapping to the intersection of those reference planes, putting those segments that are aligned with the core of the building. Okay, so these are my sketch lines, and it looks like it's on a closed loop, and it looks like I don't have overlapping lines. Now, here's another thing to know. Look at this double line here. And again, this is on the test on Thursday. These double line indicate the direction of the slab. The slab are structural components, and structural components have primary directions, gravity directions. Diaphragms have primary directions as well. And so structurally, it's important to indicate what is the direction of a slab. And you can swap the direction using this span direction option. You can pick another line, and then that double arrow will pop up. You can actually pick any sketch line to indicate what's the span direction. Because this is concrete, it doesn't matter that much. But when you use like corrugated metal assembles, it is important to understand what's the fluid direction. And so for corrugated floors, these indicate the direction of the flutes. And so when you cut a section, you can actually see the flutes in a section representation. The floors are associated with levels, so they can schedule. By default is room bounding. You can see in the instance properties. And once you finish the loop, just hit the green checkbox and the floor should be completed. Now, I made a mistake because the floor also extend in this patio. So to go back and edit the floor, select the floor, and notice how it's getting difficult to select floors from a floor plan. How you do that? You can do a window selection and just filter the floors out of that. That's one way of selecting it. Another way is just hover over, touch the edge of the slab, and then hit tab until you see the boundary of the floor popping up. No, that's the mass. Tab, tab, tab. Raster image. It's getting harder to do that using the tab. Here's floors. And the way I'm looking at it, I'm looking at the display in the lower left side. When I hit tab, I can see what the pre-selection it's cycling through in the lower left side. So you hover over and then hit tab, 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 tab until I get the floor. That's where I click. Or you can use a filter selection, doesn't matter. And I'm going to edit it because I have to add a portion of a floor right here and another portion of the floor right there for the picnic tables. So to edit a floor, you just hit edit boundary in the contextual tab. And this is going to take me back to sketch mode. And here I'm just going to grab this purple line and snap it to the edge of the picnic table area. And I'm going to do the same in this other side. So grab the edge, snap it, and then hit the green checkbox. Then when I switch to a 3D view, this is the 3D view of the roof of the floor. And I want to disable the section box. And this is where we're at right now. Okay, the floor must have, it's a concrete floor. So if I want to associate concrete material, I have to create a new type based on an existing one and give it, and give the structural core with associated structural core with a structural material. So that's exactly what I'm going to do. Select the floor, edit the type in the type properties, duplicate it. I'm going to call this concrete 12-inch. And in the structural layers, change the material to concrete. I'm going to pick the concrete lightweight. There's another one called precast. Concrete lightweight. Then this is how the material is going to represent in projection and in cut. Then hit OK. And now the floor appears with a concrete pattern. And if you look at details, then I think this is what I was looking at. I mean, the core of the wall is sitting on the edge of the floor slab. And the reason is that I'm going to make the exterior layer overlap a little bit on top of the slab. But I'm going to do that next class. Any question regarding the floors? I could have built the floors using face base as well. There's an option here called floor by face. But in this case, it didn't make a sense because I needed a single monolithic floor. I also needed to extend to the picnic areas. And so I didn't use that method here.
Cesar,
Yeah.
how do you turn off the section cut view?
Turn it on to
Or
turn
off?
it.
Well,
Oh,
I
turn
still
it.
have mine on. I wanna
Okay.
Turn it off.
In the 3D,
Yes, sir.
is scroll in the 3D view properties and disable the section box.
That's right. Thank you, sir.
There you go.
Section box. Uh-huh. Cool.
All right, let's place at least one window and then we call it off. And then we're going to complete the windows for next class. So if you look at the elevations, these have probably two types of window sizes or three types of window sizes, like a small window and then a large window. Because these elevation are in scale, I can actually measure it. And it looks like these windows are about 5 5.2 by 5.2 approximately. Windows are loadable components, and this project came with a predefined set of windows. If you scroll down in the project browser for the windows, you're gonna see that there are some fixed sizes, and these windows comes with the template that ships out of the box. But according to the sketch here, I need windows that are 5.6 by 5.6. I guess this one is the same as this one. So those, we're talking about a window that is 66 inches by 66 inches. And when I look at the list of windows available to me, I don't have a 66 by 66 window. And so what I need to do is to create a new type based on an existing one. And we've done this with walls, but we can do the same with windows. So the first things to do is to start with a placeholder and then change it, duplicate, rename, and change parameter values. So I might do this on the 3D view. And I know, according to my floor plan, that I need a 66 window in the south side. And so in a 3D view, I'm going to do it in 3D. You can also do it in floor plan. In my 3D view, I need a 66 by 66 window here. And I'm just going to grab this one, the 24 by 24. So to place a window, you can just select it in the project browser, drag it, and drop it on a wall. Component, it's a component family, so it needs to be hosted by a wall. You cannot have this type of windows floating by itself. Like a window really needs a wall in order to exist. So drag and drop the 24 by 24 and touch the wall. And there you go. The location doesn't matter. It's a placeholder. And what I'm going to do is create a new type based on an existing one. And you know the rules already. We edit the type properties, duplicate, rename, and change parameter values. So select the window that we just placed, edit the type, duplicate, and this is going to be 66 inches by 66 inches. I'm following the nomenclature standard of the types as they are listed in the project browser. But you can give it your own name if you want. So 66 inches by 66 inches. So duplicate, rename, and now I just change the parameter values. And so the width is 66 inches. You can also type 5.6, and the height is the same, 5'6". Hit apply, hit OK, and that it's my window. I also, according to the floor plan, the sill height of these is 1'6". So I'm going to go to the 3D view, select the window, and give it a sill height of 1'6". You can edit the sill height using temporary dimension, or you can use the sill height in the instance property. It's the same value. I'm going to use the sill height in the instance properties and set this to 1'6". Again, you don't have to type the feet and inch character. And then to place the window equally centered in the room, it's best to do that in the floor plan. So in the floor plan, here is the window I just placed. And I'm just going to move it. Now, how do I make sure that that is exactly half of the wall? You can make reference of the temporary dimensions that appear in plan. That's sort of eyeballing it. But if I want to be completely sure that that window is halfway, this is what I'll do. And I'm going to do this twice. I'm going to create a dimension string and then apply the equal constraint. So, and I'm going to do this twice. I'm going to create a dimension string using the align dimension. You can find the dimension commands in the quick access bar. And then create a string of dimensions. Notice how I am snapping to the center of the window, and then I'm going to snap to the center, and then this is the dimension string, and what I'm going to click is the equal control, and the equal control forces an element to be equally distanced. All right, I'm going to do it again slowly. So I placed the window. Then I create a dimension string, and you can access it in the upper left side of Revit, and create an align dimension string, snap to the wall center line on the left side, first click. The second click is the center of the wall. You're going to see that the center of the wall pre-highlight like a blue line when you hover over it. And then the third click is the center line of the opposite wall. The last click is a placement click, and you just place the string at a certain distance away from the wall. And once the dimension string is placed, hit the EQ icon that appears in the dimension string, and that's going to make the wall equally spaced in between the left and the right wall. That makes sense? So this is the south wall, the south window correctly placed correctly. And if you want to go ahead on your own and place the rest of the windows, you can do so as well. You can make use of the elevations I provided here. These are the 4 elevations in the building. And I believe the same window it's used in the north and south, but there's a smaller version of the building, of the window on the east and the west. We're going to do this the next class, create the smaller window. I believe this window might be 24 by 24. Let me check. No, this is like 2 foot, it's like 3 by 3 or 2'8" by 2'8". And that means we need to create another type for this window, and then we can place it accordingly in all the facades. Okay, so this is, I'm going to save this file. And then I'm going to save it in the Google Drive in the Miller house. I'm going to call it start 4. We're going to pick it up from here next class. If you want to access this file, you can do so as well. Miller start 4. I'm going to share it also next class. And let me open the final house to see what we're going to do next class. We're going to place all the different windows, and then we're going to talk about curtain walls. And we are going to build this big window at the ground level, the entry levels. We're going to build it as a storefront. We are also going to apply different materials, the final materials. This is a plank veneer that's about 8 inches wide. So I'm going to show you how to create new materials based on existing ones, apply new textures. And then we're also going to focus on the furniture. So we're going to load some typical furniture like these bunk beds and queen beds, and then we're going to focus on the kitchen. So we're going to do a lot of interiors in the next couple of weeks, and create a custom piece of furniture. Like this is a custom counter. I'm going to show you how you can create one. All right. Okay, so sorry, my eyes are crying. I don't know why. I might be too excited with it. So feel free to stay over if you want me to, if you need help on anything. Otherwise, I'll see you guys Thursday again. All right, and I'm gonna find out what's happening with the live stream. I haven't done it in a while, so I don't know if it's Autodesk preventing me from using the service or if it's something on my computer. I'll find out.
All right, Cesar, I'm gonna miss next Thursday, but I'm gonna pick up the video over the weekend.
Okay,
I'll look for that and stay caught up.
cool then. All right. Well, see you guys Thursday.
Great, thank you very much.
Have a great night.
Bye. Thank
Have
you.
a
Thanks, Cesar.
Good evening.
Caesar, I
Yes.
have a question. Where
Yeah.
are the snap points? Snap,
The snap points
like
in Revit.
yeah.
Good question. Snap points. It's a setting that you can force elements in Revit to snap by typing. Let me show you an example. I'm going to create a wall, and I want this wall to go perpendicular to this.
Yeah.
So I type on the fly SP, and
SP.
SP is snap perpendicular. You see the
Oh,
perpendicular
okay.
thing?
Yeah.
Or if I wanted to go to the midpoint, you go SM, and that's going
Oh.
to snap to the midpoint, and you see the different icon there.
Right. Right.
Or you can type SE, and that's snap endpoint.
Okay.
So Control V.
So we have to type every time. There is no like icon.
No, there's no
No.
icon.
Oh, okay.
Snap endpoint, snap perpendicular,
Okay.
snap midpoint, snap to the quarter of
Okay.
a circle, snap N is near, snap near a point.
Snap. Yeah.
And there are many others. Oh, there's one's called snap parallel, which is parallel to another line. And
And if there are a lot of divisions on the line or any wall, like
oh, you mean
means we divide one line into 4 parts.
yeah.
The nearest we can choose, right? Maybe the nearest.
Yeah,
Yeah,
there is enough. For example, if you wanted to divide this in 4 portions, like if there's a
Right.
way to snap,
Yeah, 4.
that was
Yeah.
your.
Yeah.
No, there's not. In Revit,
Okay.
you know how in AutoCAD you can create
Yeah.
a grid, and then in the grid you can snap everything.
Snap. Yeah. Oh, it's not there. Okay.
There's not like that here. I mean, it's like you can stretch things. You can make length changes to elements.
Okay.
You see how snap in certain
Right.
increments, but this is the result of the zoom factor.
Okay.
So if I zoom more, then look at the temporary dimension, it's
yeah.
snapping every 1
Okay.
inch. But that's pretty much you can do. Or if I
Mm.
snap out a lot, then the snaps happen every couple of feet.
Right. Right.
So
Yeah.
depending on how this, depending on the zoom factor on the view,
Mm.
you can snap to different increments.
Right.
And I believe those settings are under the manage tab, additional settings.
Okay.
Or their options.
Okay.
There is a place where I can set, maybe let me find where that is, because I forgot
Sure.
where that is.
Okay.
Okay,
Yeah,
anybody
got
else?
it.
Did you have another
Thank you.
question?
No, thank you.
Were you able to follow up? Just question. Yeah,
Yeah.
okay. All right, so I see also Casey, Michelle, and Jessica. You guys have any question?
I'm good.
Nope. Just listening.
Yep.
Okay, Casey.
All right.
Yeah, go ahead, Casey.
No, I'm good. No
Oh,
questions.
you're good. Okay.
Yep.
And you,
Thank
Michelle?
you.
Yep.
I'm good.
Yep.
Okay.
Have a good night.
All right.
Have a good one.
And
Thank you.
Thank
Jessica,
you. Thank you.
okay?
Have a good night.
I'm good. Thank you.
Thank you. Bye bye.
Bye.
See you Thursday.
Bye-bye.
See you.
Bye-bye.